Hello everyone. In this video, I'm going to show you how you can build this snake game by using just plain JavaScript, no libraries, no frameworks, just JavaScript, HTML, and CSS. And there is a ton to learn in this video about game development and also web development as a whole. So with that out of the way, let's get started now. Have you ever wanted to work fully remote, but have a hard time finding remote jobs? Well, luckily for you, Remote.work, today's video sponsor, has a huge listing of remote-only jobs where you can go and find your dream remote job. They have tons of different jobs across all different spectrums, including programming, and they're with tons of different companies all across the world, so you can really find the perfect job that fits your exact need. On top of that, they have different types of jobs from full-time, part-time, contract, and even internships. So it doesn't matter your skill level, you can find a job on Remote.work. So make sure to check out Remote.work using the link down in the description below. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now to get started, I have a working version of the game on the right, and you can see as soon as I click one of the arrow keys, the snake is going to start moving, and I can click another arrow key, and of course, if I eat one of these food pieces, the snake is going to grow and continue on like this until, for example, I run into myself or a wall, and then it says that I lost, and I can click OK, and it's going to restart the game for me. So it's a fairly basic game overall, but there's a lot of extra customization and configuration we do. For example, I can change one single variable. If I come in here, and now the snake is going to move twice as fast as it was moving before. I can also change another variable. If I just change here, this, and I click refresh, you can see when I eat a piece of food, the snake is going to get longer by 3 pieces at a time instead of 1. So there's a ton of different ways you can customize this based on how the code's set up. So it's a really great project to see how you can make modular and refactorable code. So to get started with making this project, the first thing we need to do is to create an index.html file. And then inside of here, hit exclamation point and tab, and that'll fill out all the boilerplate HTML you need to get started. We're just going to give this a title of snake here. And inside the body, we actually only need one single element. It's just going to be a single div, and this div is going to have an ID, which is just going to be game board, just so we know that this is where we're going to put all of our different game pieces. And sometimes you may see games made with canvas instead of with actual HTML elements. And the reason we're using actual HTML is because CSS Grid is perfect for making snake. So we're going to use CSS Grid heavily to take advantage of how we can use it with snake. So now, speaking of CSS Grid, let's get some styles in here. And I'm just going to do these inside the HTML because we don't actually need that many styles. The first thing we want to do is center this grid content inside the middle of our screen. So we want to select our body, and we're going to set the min height equal to 100 VH. Whoops, VH, just like that. And we want to set the width the same way, 100 VW. And let's just make sure we set the height to 100 VH. We're never going to have any scrolling, so we don't need to worry about min height. And if we change the display here to flex, set justify content to center, and align items to center, we're essentially going to be centering our grid section inside the middle of our screen. So this game board is going to be in the dead center of our screen. Lastly, let's just remove all of our margins. So we'll set our margin to 0, and we'll put a simple background color, which is going to be black. As you can see, we have the black outlines around our grid border here. Now we can select that game board, and for our game border, let's just set a background color here, which is going to be CCC. That's this gray color that you see on the right. And to get our width and height set up, let's just set our width here to be 100 V min. And what this is going to do is it's going to take whichever direction is going to be the narrowest. For example, our width right here is the narrowest. So V min is our width. But if we, for example, were to expand our screen, you can now see that V min is our height because our height is the shortest width. So now our width is going to be 100% of the height, and our height is going to be 100% of the height. And the reason that we're doing this with V min is so that way always we're going to have a square shape that's going to be as large as possible to fill our entire screen. So with just that set up, what we can do is actually run this with live server. So we'll just right click, open with live server. That's going to open up on the right hand side here. And as you can see, we have that gray section, which is going to scale perfectly based on the size of our screen. Now the next thing to do is actually to set up our grid. So we want to change this to be display of grid. And we're going to change it so that we have 21 columns and 21 rows that are all the exact same size. And we want the browser to automatically calculate what size this is. We don't want it to always be 50 pixels or 40 pixels. We want it to just be 21 even squares. That way, no matter what size our browser is, the Snake game is always going to have the same 21 squares. So in order to do that, it's also fairly straightforward. We change here our grid template rows, and we're going to set this to repeat, and we want to repeat 21 different times, and we're going to give them a width of 1 fr, which is just going to be essentially all the rows are going to be the exact same. And we could do the exact same thing here with our columns. So with this 1 fr and 21, we now have 21 rows and 21 columns, and each one is going to be evenly split up so they're all the exact same width and the exact same height. So now we can actually see this by just inspecting over here. And if I just hover over our game board, you can see this grid appears on the right side of our screen. And that grid is our 21 by 21 grid where our entire Snake game is going to take place. Now the very last thing we need to style is going to be our different elements, for example our snake piece and our food piece. So let's just come down here and select our .snake, and we're going to select our food. And our snake is going to have a background color, which is going to be that blue color that you see, which we're just going to say HSL 200, 100%, and 50%. That's that blue color. And for the food, we're going to do a very similar thing, but we want to have a yellow color, which is just going to be 50 as our HSL. And then lastly, we're going to need a border. And I actually want this border to scale with the size of our grid. So when we have a really big screen, our border is going to be bigger. And when we have a really small screen, our border is going to be smaller. So in order to do that, we can set it based on our vmin. So we can say 0.25 vmin, and that's going to be the size of our border. Then we can say in here that we want it to be a solid black border, and we're going to give that to our food as well. So now we have our snake piece and our border for the food piece set up properly, and that's all of the CSS and all of the HTML we need for this entire project, so we can move on to the most enjoyable part, which is going to be our JavaScript. So let's create a JavaScript file called game.js. This is where our base JavaScript is going to go, and in order to import this, we're just going to import it up here in the head. We're going to say script. We're going to want this to have a source, which is game.js. We want to defer it so it loads after our body. And we also want to set the type here to be module. And the reason for this is that we're actually going to use import and export statements to have multiple JavaScript files so we can break apart our logic for our snake and our food into different files to make it easier to work with and easier to reason with our code. So we're going to use this module here of our type just so that JavaScript and our browser knows that we're going to be using import and export to make different files instead of just one giant JavaScript file. So now if we save that, we can close out of this index.html and move on to our game.js. Now the very first thing we need to do in our game.js is set up what's called a game loop. And a game loop is just a function that's going to repeat itself over and over and over again on a very set interval. That way you can constantly update your render. So for example, as our snake moves, we can constantly update our snake position, as well as constantly update our food and do all of the game calculations we need on a very set time. So in order to set that up, what we need to do is create a function. So we'll call this function main. And this function is going to take in the current time. This is essentially the exact timestamp of when this function runs. So inside of this function, we're going to have that current time, and then we want to recall this main function essentially immediately so that way we can set up another loop that's going to happen after this. Essentially, our main function is just going to loop over and over and over and over and over again forever. That's the purpose of a game loop. So to do that, we can use window.request animation frame, and we're going to pass it in that main function. And what this does is it says, okay, browser, tell me when I can actually render my next frame. I'm requesting a frame to animate my game, and this is going to tell us what the current time is when we actually go to render that frame. So it's going to say, okay, I want to render a frame. It's going to wait till it can render a frame. Then it's going to call our main function with the current timestamp of when that frame is going to render. So when we do this, if we just put in here a console.log of current time and make sure that we do one last window request animation frame of main. This is just so we can start our loop the very first time. Now if I come over here and inspect our page and go into the console, you can see we're getting printed out the time from when we first initially decided to run our window.request animation frame. And it's just constantly counting up. This is in milliseconds. So in order to take advantage of that, we want to figure out how long it's been since last time that we rendered. So we're going to create a variable We're just going to call it last render time, and by default that is going to be 0. And then we're going to update our last render time down here. So down here we're just going to say last render time equals, and we're going to set it to our current time. So essentially every time we come through here, we're setting our last render time to our current time, so that way we are constantly having a new last render time. And then what we can do is we can come in here and get the number of seconds since last render. So we can say seconds since last render is going to be equal to our current time minus our last render time, and we want to divide that entire result by 1000 since this is in milliseconds, and we want to convert to seconds. So now let's actually log that out down here at the bottom. And if we do an inspect real quick, you can see inside of our console, we're getting approximately, it looks like, 0.006 to 0.007 seconds of delay. So essentially 6 to 7 milliseconds of delay between each one of our render frames. And with our game, we don't need to run that fast. We don't need to update the snake's position every 6 milliseconds. I mean, if you look over here, if I refresh this real quick, you can see the snake really doesn't move that fast. So in order to actually update the snake's position, instead of running this every single millisecond or every 6 milliseconds, we're going to essentially not do anything in our main function unless we hit a certain threshold. And we're going to call that our snake speed, which is going to be a constant variable. So we'll say snake speed, and we're going to set it equal to 1, for example, to start with. This is going to be how many times the snake moves per second. So let's actually set that to 2. So it's going to move 2 times per second. So in order to calculate if we need to actually move, all we need to do is get our seconds since last render. And all we need to do here is check if the seconds since our last render is essentially less than the time between our renders, which would just be 1 divided by our snake speed. Since our snake moves at 2 times per second, 1 divided by that would be the number of seconds between each move. So we have a half a second between each move. And if the time since last render is less than half a second, then we don't need to move our snake. So we can say if that's the case, all we want to do is just return out of here immediately. But we want to make sure that we always request our next animation frame no matter what. And we only ever update our last render time if we actually get below this check here, because that means we're actually going to render our snake. So instead of here, we can just put the text of render. And now if I come over and inspect the page, you're going to notice that in our console, about 2 times per second, we're getting the text render printed out. And if we increase our snake speed to, for example, 20, and I come over here, you can see this is being printed 20 times a second. And if I drop it down to 1, it's going to be printed out once per second. So we can directly control how fast our game actually updates based on this snake speed variable here. And at the beginning, when I was changing one variable to change how fast our snake went, it was this exact variable here. So now that we have all of this render code set up, let's come down here and actually set up our logic for our game. Almost any game you work on is going to be broken into 2 different steps. You're going to have an update loop, and this update loop is going to update all of the logic for your game, and then you're going to have another loop, either called draw or render, and this is what's actually going to draw everything on the screen based on this update loop. So this update loop is going to move the snake to the correct position, but not actually draw it. It's going to update if we ate the food or not, so it's going to make the snake longer or shorter. It's also going to determine if we lost the game because we ran into our own tail or ran into the edge of the screen. And then in the draw, what we're going to do is take all of the logic from update and say, okay, where is our snake now? Let's actually draw him in the correct position. Let's draw the food where it needs to go and all of that stuff. So we broke this into 2 distinct separate sections. So let's create those functions real quick. We'll just come down here a little ways. We'll say function update. And we're going to have another function for draw. Whoops. And inside of each one of these, all we need to do is update our snake and our food, and then draw our snake and our food. So let's first get started with our snake. We'll create a new file. We'll call it snake.js. And inside of here is going to be where all of the code for our snake goes. So let's actually take this snake speed and move it into snake.js. And we're just going to export this so that we can use it inside of here. So we can just come down here, import, and we want to import snake speed from /snake.js, just like that. And if we come over here and make sure, whoops, that we render and inspect this, it should still be printing out render, just like that. So everything is still working. And now inside of our snake.js, we want to have a function for update. This is going to be for updating our snake, and a function for draw for drawing our snake. And again, we're going to need to export both of these functions so that we can use them inside of our game.js. So let's make sure we import these. We're going to import update, and we're going to call this update snake. and we're going to import our draw, which we're going to call draw snake, just like that, if I spell snake correctly. And now what we can actually do is take these functions, update snake and draw snake, and just call them in our main update function. So we have update snake, and we have draw snake. So now we can just remove this render here. Instead of our snake, I can console.log draw snake. And if I come up here and do the same thing, but for update, you should see when we inspect that these are being rendered out first update and then draw. And as you can see, it says update draw, and this happens every second based on our snake speed that we set. So we can change this to 5, and now you can see it's 5 times quicker. Let's put that back to 1 for now, and we can close out of this. And the first thing that I want to work on is going to be actually drawing our snake, because I think that's going to be the most visual and most interesting. But before we can start drawing our snake, we need to figure out how we're going to represent our snake. And the brilliant thing about using a grid-based system is that we can represent our snake as essentially an X and a Y position. So let's create a variable. We're going to call it our snake body. And this is going to be an array of X, Y positions, because our snake essentially is just a bunch of different segments, and these segments all are in a particular X, Y position on the grid. And the very center of our grid is going to be at X11 and at Y11. So I want to draw our snake at X11 and Y11 right at the very start in the very middle of the screen to begin with. So in this draw function, what we can do is take our snake body, and we want to loop through each one of our different segments is what we'll call them. Essentially each piece of the snake we want to loop through, and I want to draw this to the screen. But of course I need to draw it to our game board. So we're going to need our game board passed into this draw function so we can actually add our snake to it. And then what I want to do is create essentially an element. We're going to call this our snake element, and we're going to set this to document.create element, and this is going to be a single div, and this is going to go inside of our game board at a particular XY coordinate. And since we're using grid, we can directly set that XY coordinate very easily. We can say down here, our snake element dot styles, or dot style, I'm sorry, dot grid start, grid row start, and that's going to be equal to our X. So we can say segment.x is our row start, and we can do the exact same thing, but we want to do, grid style dot grid column start, and this is going to be our Y position. So now we've set the X and Y position based on our grid row start and our grid column start, and then we can just say game board dot append child, and we want to append that snake element. And in order to make sure we can visualize this, we can take our snake element and we can set the classes so we can get our class list. We can add in our snake class just so we can get that nice blue color. Now if I save and come back over here, you're going to notice nothing actually works yet, and that's because we need to pass that game board in. So down here, let's pass in our game board, and we first need to grab that game board by saying const game board is equal to document.get element by ID, and the ID is game board. And as you can see, our snake has popped up, which is exactly what we want. Now let's focus on how we get our snake moving. And to begin with, I'm going to think about how we would move our snake if we, for example, had a 3-segment snake. So let me create a 3-segment snake just so we can think about this. We're going to do an X10 here and an X12. So this is just going to be a straight line snake. And if I save, you can see we have a straight line snake. And now let's say that the snake moves up 1 position. So it's going to have its new head right above its current head. The way that this works is that we're going to move its current head up 1 to the new position. And then where does the body part go? Well, the body is also going to move up 1, and then the other body piece is going to move up 1. So that's pretty simple. We just add 1 to every single piece to move it upwards. But what if the snake head moves to the right? Well, we don't want to move all of the body pieces to the right, because if we did that, for example, if we made our snake move all of its body pieces to the right, it's not going to look right because the snake is going to move as a whole piece, when in reality, it's supposed to follow its head around. So an easy way to get around this problem is we move the head to the right one, and then we move the body piece right behind the head to where the head used to be. And we move the body piece behind that one up 1 as well to where the old piece used to be. So essentially we're just shifting our array up 1 and then making the head the correct position where we want it to be. So inside of our update function, that's exactly what we're going to do. We are essentially just going to take the position of a given segment, and the segment after that is now going to move into that new position. So let me show you how that works inside this update function real quick, because it's a lot easier to see inside the code. So we're going to need a for loop here, because we only want to loop through every segment essentially except for our last segment, because the last segment of our snake is going to essentially disappear. The position where our bottom of our snake is no longer going to have a snake in it ever, so we don't need to worry about that position. So what we can do is just say let I equals snake body dot length minus 2. This is going to give us the second to last element in our snake. So we're going to start from the bottom and work our way up. Then we're going to say when I is greater than or equal to 0, we're going to stop our loop, and we're going to subtract 1 from I each time. And now inside of this loop, what we're going to do is we're going to take our snake body of our I plus 1 element. This is going to be the element before the one we've selected. So on the very first iteration, I is going to equal the second to last element, and I plus 1 is going to be our last element. So we're going to take essentially our previous element, in our case our last element, and we're going to set it equal to our current element in that I position here. And we need to make sure that we set this as a brand new object. So we're just going to spread out this object into a new object. That way we don't have any reference problems. This is going to create a duplicate of our snake at position I and set that to our snake at position I plus 1. We're essentially shifting our entire snake so that everything moves forward a position. It moves to where its parent essentially is in the snake's body. Then, once we've done all of that, the very last thing we have to do is update the head based on where we're moving. So we can say snake body of 0, this is going to be head, and we're going to update the x by adding to it some kind of movement. Let's just say 1. For now, we're going to hard code this as 1, and for the y position of the head, we're just going to plus equal this with 0. We're not going to move the y position. So now if I save this, you're going to notice something interesting. As you can see, our snake is moving, but it's moving down instead of to the right. So clearly our x and y are flipped. And as you can see down here, our row should be set to our y, and our column should be set to x. So if we save that, we should now see that our snake is moving to the right, which is exactly what we want. But you'll notice this weird thing where it's kind of showing all of the pieces of where the snake used to be. And this is because when we draw our snake, we aren't removing all of the previous pieces of the snake. What we need to do is take our game board and set the inner HTML to nothing. This is going to clear everything in our view. So now if we save, and you can see we render, our snake is going to move without actually showing any previous pieces behind it. So this is exactly what we want. And in order to make this look a little bit better, let's actually add 1 to our y instead of our x. And as you can see, it's much better properly following the snake as it's actually making these turns, as opposed to just always moving the entire snake in one direction. We can see that a little more if we add even more segments to our snake. It should be even more obvious. So let me just add these extra segments, and we'll save one more time, and you should see that it's going to move down, and each one of the pieces of the snake is going to be following, which is exactly what we want. And one thing that's kind of interesting you'll notice is as y increases, we actually move down. That's an important thing to realize, because when we're going to input our input system, we need to make sure that -1 for y is moving up and +1 for y is moving down. That's something that I always mess up myself. And speaking of input, let's actually work on making it so our keyboard is going to work and actually allow us to do inputs instead of hard coding our movement inside the update function. For now, I'm just going to comment this out so our snake doesn't move all over the place. And I'm going to create a brand new file, which is going to be called input.js. This is where we're going to get all of our input information from. So inside of here, we want to create a variable which is going to be called our input direction. We're going to set that just to x0, and it's going to be y0. By default, we don't want our snake to be moving anywhere. And then we want to create a function. We're just going to export this, and it's going to be called get input direction. And all this is going to do is return our input direction, just like that. So now inside of our snake here, we can call that get input direction function, and it's going to import that for us automatically, which is really nice. And then that's going to give us our input direction. So we can say const input direction is going to be equal to that. And down here, we can update our snake position based on our input direction. So we'll say input direction.x and input direction.y. And now if we save, you should see that our snake doesn't move anywhere. But of course, looks like we're getting an error. So let's inspect and actually see what that error is. In our console, it says failed to load resource. The server responded with the 404. It looks like my automatic import didn't include the .js. So if I save that, you can now see our snake is right where we want it to. And you do notice some weird movement with it. That's just because our snake right now is longer than it should be. Let's clear this out so we just have one snake piece that's 11, 11, just like this. And now if we save, we'll have a snake right in the middle. It's not moving, it's not doing anything, it's just staying exactly where it should. And now, inside of our input here, we can actually set up the code for modifying this input direction whenever we click a key. So we can just add an event listener to our window for key down. This is going to get an event. And inside of here, we're just going to use a simple switch statement based on our e.key. And this e.key is either going to equal arrow up, down, left, or right. So we can say case of arrow up. And then what we want to do is put a colon after here. And inside of here, we're going to have our actual case. We're going to set our input direction here, which is equal to x, which is going to be a 0, and a y, which is going to be -1, because remember, -1 moves us upwards. And then we just want to break out of here. And we're going to do this essentially a few more times, one for each of our different types of cases. Let me just fix the indentation here. And there we go. So this one is going to be arrow down, which in our case is going to have a +1 in the y direction. Then we're going to have arrow left, which is going to be 0 in the y direction, and -1 for x. And lastly, we're going to have arrow right, which is 1 in the x and 0 in the other direction. There we go. All of our indentation should be fixed just like that. So now we have our input direction being set. And with this, we can actually just save this. And now whenever I click an arrow key like up, you can see the snake moves up, left, and it's going to move to the left, down, it's going to move down, and right is going to move right. But one immediate problem you'll notice is I can move from right to left, or I can move from up and I can move back down. And that's something you cannot do in the actual snake game. Your snake can't reverse onto itself. So we need to set up some checks to make sure we can't actually move from up to down or from left to right. So we actually need to store our previous input direction based on the last time we got our input. So inside of here, we can just set a variable called last input direction. We're going to set it to our input direction. And let's create that variable. We'll say last input direction. And by default, we'll just set it to 0, 0. And then in our arrow up, we can say if our last input direction dot y was not equal to 0, then we essentially want to break out of here. What this is saying is if we are currently moving up or down, just ignore this. We don't actually want to worry about up press because we can't press up when we're already going down. We're going to do the same thing for our arrow down. If we're already moving up, we can't actually start moving down. And then instead of here, we're going to make this x, because if we're already moving to the right, we can't move to the left. And down here, same exact thing. Now if I save and I press up, you're going to notice I start moving up. And if I click down, nothing's actually going to happen. I'm not going to be able to move down. And if I move left, I can move left just fine, but I cannot move to the right. If I can move down, I can move right, I can move up, but I can't swap direction 180 degrees. So we fixed that bug, which is really important. Now the next thing that we can work on is going to be our actual food. But before we do that, I'm going to bump up the speed of the snake. It's really slow right now, so we'll bump this up to 5, just so it's a little bit more enjoyable to watch as it moves a little bit faster. That's much better. And now we can create a new file called food.js. And inside of here, we're going to do a very similar thing we did to snake. We're going to have an update and a draw function. I'll actually just copy these over. Clear out the update function is going to be a lot different, but our draw function is actually going to be very similar. We don't have a snake body anymore to loop through, so we can get rid of that. And we're going to have a food element instead. And this food element is going to be based on a variable we're going to create, which is going to be called food. And we're just going to set this to an object which has an x of 0, and we're going to give it a y of 0 for now. Eventually we'll make this random, but for now we'll just hard code it into x0 and y0. And now we have our food element. And our food element style for the grid row and column start right here. They're going to be exactly the same, this y and this x, but it's going to come from food instead of segment. So we can set our food here, and we want to add a class of food to this instead of snake, and then make sure we take our food element and add it to our game board. So now we have that done. Inside of our game, we can actually import that. So we can say import food as, I'm sorry, not food, update as update food. And we want to get draw as draw food. And we want to get those from /food.js. Whoops, .js, just like that. And down in here, we can say draw food, pass it in our game board, and we can call update food as well. Now, if we save, you can see our food is in the top left corner. And if we change this to, for example, x of 10, you can see it's going to move over to the 10th row, or the 10th column, I'm sorry, in the very first row. And actually something super important to note is that CSS grid starts at 1. So instead of this being 0, we actually need to make this a y of 1 because those are actually different positions on the grid. They look identical over here, but they're actually different. So we need to make sure everything is going to be between 1 and 21, and 0 is actually technically outside of our grid. So that's an important thing to note. Now the next thing that we need to work on is what happens when the snake eats the food. If I move the snake all the way up here over top of the food, you can see nothing actually happens. I just go right underneath of it. Clearly, that's not how you're supposed to play snake. So what we want to do is set up some form of expansion rate. We're going to set a constant variable called expansion rate, and this is going to be how much the snake grows when it eats the food. We'll set it to 1 for now, which means it'll gain 1 new segment every time it eats a single piece of food. Then what we're going to do is inside of our update, we want to check if the snake is currently over top of our food, because that means that they can eat it. So we can just come in here and say if on snake, which is a function we're going to create, which is going to pass in a position on the grid, for example, our food, and it's going to check, is this on our snake? And if so, it's going to return true. Otherwise, it's going to return false. So if we're on top of the snake, then we want to execute some code to eat the food. So we want to first expand our snake. So we'll call a function called expand snake, and we'll pass it in that expansion rate. So we want to expand our snake by 1, and then we want to set our food to a new position. In our case, we're just going to hard code this to an x of 20, and we're going to set it to a, y of 10. Just for now, it's going to be hard coded there, but eventually we're going to have to update this to somewhere else. We're going to have to make sure this is random. But before that, we need to make an expand snake and an on snake function. So in our snake, let's export expand snake. And this is going to take in a number for how much we expand. Make sure we call this a function as well, and give it here an amount. And we're going to essentially take a variable called new segments, and we're going to add in that amount just like that. So let's create our new segments, and we're going to default that to 0 because by default our snake is obviously not growing. Then we're going to export another function called on snake. This is going to take in a position, and it's going to determine if this position is on our snake. We can just come in here and return snake body.sum. And we want to loop through each one of our segments. Segment, just like that. And for each one of our segments, we want to essentially check if it's on our snake. So we're going to compare our position with our segment position to see if they are equal. So to do that, we're going to create a function, which is going to be called equal positions. And we're going to pass it in a segment and a position. And let's just create this function down here for now. Eventually, we're going to move this out. But we'll create equal positions, and it's going to have a position 1 and a position 2. And all we want to do is return if some criteria is met. So position 1.x is equal to position 2.x, and position 1.y is equal to position 2.y, just like that. Let's just put this all in one line. Actually, I think it'll all fit. There we go. And now essentially, if our two positions are exactly the same, this is going to return true. And if that's the case for any of our snake positions, that's what .sum means. So if any part of our body equals this position we pass in, then on snake is going to return true. So let's import that in our food here. We can say import on snake and expand snake from /snake.js. And as you can see, everything renders over here. And if we come up and eat this food, it should disappear and move. And that's exactly what we got. But of course, our snake hasn't expanded itself yet. So let's make sure our expand snake is actually working. So essentially in our update, we need to take our new segments and add them onto our snake. So let's create a really simple function. We'll do it all the way down here at the bottom. We'll call this add segments. And this function, all it's going to do is it's going to take our new segments and add them onto the bottom of our snake. And we're going to call this every time we update. So in here, we're just going to call add segments, just like that. So now inside of our add segments function, we want to just loop through all of the segments. So we can say let I equals 0, I is less than new segments, and I++. So for each one of our new segments, all we do is we take our snake body and our snake body dot length. This is going to be essentially one more index than our current snake length. So this is going to append a new element onto the end of our snake. And we're just going to set it equal to our snake body dot length -1. And it's going to be a brand new duplicate of this. This would be essentially the same as if we did snake body dot push we just want to append that onto the end. And this is a little bit more clear, so we'll go with snake_body.push. So we're just taking the very last element of our snake and duplicating that onto the end of our snake. So if our snake is currently one position, it's going to duplicate that one position, and then as our snake moves, it's going to slowly expand itself outwards. So we have our add segments done, and inside of our update, we also have our move code done. So let's save this, go up and see if this actually works. And as you can see, our snake is constantly expanding itself. So clearly this is not what we want. And the reason this is working like this is because we're never actually getting rid of our new segments. So what we need to do inside of this add segments function is take our new segment and we set that down to 0. Now what's going to happen is it should no longer add any more elements to itself other than the number of elements we told it to. And in our food, if we change our expansion rate to 5, you should see that now our snake is going to increase by 5 instead of just increasing by 1. So if we eat this, you can see it's now 5 longer than it was before. And as you can see, everything is moving exactly as we want it to. So now let's move on to the problem of actually randomizing our food position. Let's create a simple function called getRandomFoodPosition. And what this is going to do is return to us a new position for our food every single time it gets eaten, and it's going to return a position that is not already on the snake. That's the most important characteristic of this. So we can just create a variable called new food position, just like that. And in order to make sure we create a food that's not on the snake, we're going to use a while loop. And whenever our new food position is equal to null, or whenever we are not on the snake with our new food position, so we can say currently whenever our food is null or our food is on the snake already, then we want to essentially get a new food position. So we'll say new food position equals random grid position, which is a function we're going to create, which is just going to give us a random XY value inside the grid. So what this function does is every single time that it executes, it's going to get us a new food position. And then if that new food position is already on the snake, it's going to get another one and another one and another one. And it's going to loop like that forever until it finally finds a value that's not already on the snake. So we can set our food equal to that getRandomFoodPosition. We can do that up here for our default first food and down here when we set our new food. They're both going to be randomized. And now the only thing left to do is to create this random grid position function. To do that, we're just going to create a grid.js, and inside of here, we'll export that function, which is going to be called getRandomGridPosition. And actually, this is just called random grid position. There we go. And all this does is going to return to us a new x and a new y value. And this x is going to be based on a formula for calculating a random number between 1 and the size of our grid, which is 21. So we can say math.floor of math.random, and this is just going to give us a random number between 0 and 1, and it's always going to be slightly less than 1, so 0 and 0.999999 repeating forever. We're going to multiply that by our grid size, which is 21. We're going to put this inside of a variable just to make it easier to work with. So we could say up here, const grid size is equal to 21. And then what we want to do, so we have a number between 0 and 0.99999. We're multiplying it by 21, so that's going to give us a number essentially between 0 and 20.9999999, and we're getting the floor of that. So right now we're getting a number between 0 and 20. So in order to get a number between 1 and 21, we just need to add 1 to the end of this. So now we have a number between 1 and 21, which is going to be on our grid, and it's going to be completely random. We'll do that both for our x and for our y. Now, inside of our food, we just need to import that. So we can say import random grid position from, grid.js, and we need to make sure it's / like that. And now you can see our food position should be randomized every single time we pick it up. So there we go, our food moved down here completely randomly. Now it's moved up there completely randomly and all the way down there. And you notice it's never going to land anywhere that the snake already is because we're checking that down here in our getRandomFoodPosition. We're checking to make sure it's never on the snake. It'll get a new random position if it can't find one. So right now our game is mostly complete. We have our snake moving around, eating food, and the only problem is that there's no way to lose the game. If I, just refresh here, you can see I can run into the wall and it doesn't matter. It just works. No errors are thrown. Everything's fine. I can even move the snake around, move him back up, try to get him off of this. It really doesn't make any sense. None of this actually works. We need to add in a failure state. So to do that, we're going to go back to our game.js, and inside of our update, we're going to check for failure. So we're going to say check for death. If this is going to happen if the snake runs off of the grid or if the snake runs into itself. And we'll just create that function down here to make sure we check for that failure state. And in this failure state, we're going to set a global game over variable equal to either if we are outside the grid or if our snake has intersected itself. We'll say snake intersection. So this outside grid, we just want to check if the head of our snake is outside. So we're going to create a function called get snake head, which is going to give us the head of the snake. And if the head of the snake is outside the grid, we lose. Or if the snake intersects itself, which is another function we're going to create on the snake to determine if the snake head has intersected with its body. And we're going to create that game over variable all the way up here. So we'll say game over, and we're going to set that to false to begin with, obviously. Then to actually do our game over state, inside of our game loop, we're just going to check if game over, then we're just going to, for now, alert you lose. We're going to set this up to actually restart our game, but for now we'll just say you lose, and we're going to make sure that we return here just so we don't actually run the rest of our code. And now if we save, we need to make sure we implement this outside grid, snake intersection, and this get snake head. So let's do outside grid first, and that'll go inside this grid.js. So we'll say export function outside grid, and essentially all we need to do is check to see if the position that we pass into this is going to be greater than our grid size, which is 21, or if it's less than 1, which is our minimum grid size. So let's just come in here and we can say return, and we want to return position.x is less than 1, or the position.x is greater than our grid size, or if our position.y is the same thing, less than 1, or our position.y is greater than grid size. So essentially, if we're anywhere outside of our grid, this will return true, otherwise it'll return false. So that's outside grid taken care of. The next thing we need to work on is going to be the function called get snake head. So in our snake, let's just export a function called get snake head, and this is just going to simply return snake body of 0. Pretty straightforward. We know the first element in our array is always going to be our head. Now the very last thing inside of our game is going to be snake intersection, and this one's a little bit more complex. So let's export the function snake intersection, just like that. And essentially the way to determine if the snake has intersected itself is by determining if the head of the snake is touching any of the other body parts on the snake. So we can just return on snake, we can pass in the head of the snake. But one problem is that this is going to loop over the head of the snake. So of course it's going to compare if the head of the snake is the same as the head of the snake, and that's going to always return true. So we want to ignore essentially the head of the snake. So we'll say ignore head is going to be set to true. This is an option we're going to pass to on snake. And we're going to have here ignore head, which is by default going to be equal to false, because if we don't pass it in, we want this to be false. We're going to make sure that we pass in an empty object by default in case we don't pass anything. Then what we can do is take our segment and the current index, and if down here, if ignore head is true and our index is equal to 0, which means we are on the head, we just want to return true. We're just saying ignore the head completely. I'm sorry, this should actually be return false, because we don't actually want this to say that the snake head is on the snake head, because we already know that. We don't need to worry about that. We're completely ignoring the head. Now, this snake intersection is going to check the head against every other position on the snake, and if any of them are the same, then that means that the snake has touched itself, and you obviously lose. So let's import all of these different functions. We're going to have get snake head, we're going to have snake intersection, and we also need to import here from our import. Let's see what that was called. It was called outside grid. So we're going to import outside grid from our /grid.js. Now if we save, you can see everything is rendering, so that's good news. It should work. Let's go up and collect some food to make sure that works. As you can see, this is all working exactly as we want. And let's try running off the screen. As you can see, we get an error saying you lose, so that's exactly what we want. We'll click OK for now and just refresh manually. Now let's go up here and see if the snake intersection works. So we're going to collect a bunch of food and then just run into ourselves. So just like this, if we run into ourselves, you can see it says you lose. So again, our error check has worked. This is exactly what we want. Now the last thing for us to do is to make this game over actually reset our game. So it's actually pretty straightforward to do that. All we need to do is put in an if here. And we're going to use something called a confirm. That's going to be a box that pops up, which is going to allow us to get a true or false result. So we're going to say you lost, press OK to restart. There we go. And essentially, if this returns true, we want to do something. Otherwise, we're going to do something else if it returns false. And if it returns true, we're going to set the window.location equal to essentially the current location that we are already on. And this is just going to refresh our page, which is essentially going to restart our game. And down here, we just want to make sure that we return, because if they don't press OK and they actually just exit out by hitting cancel, we don't actually want to continue to run the game. We want the game to be stopped. So we're going to save and we're going to refresh this to see if this works. Let's just go up and immediately lose. And you can see it says you lost, press OK to restart. And when I click OK, you can see it refreshes the page. And if I go up here and instead of hitting OK, I click cancel, you can see it just gets rid of that pop-up and our game goes back to how it was, but it doesn't start moving again. It's just completely frozen because this is the lose state and we don't want everything to start moving again. And that's all there is to creating this snake game. If you enjoyed this video, make sure to check out my other videos linked over here and subscribe to the channel for more videos just like this. Thank you very much for watching and have a good day.